Welcome back, Geometry Scholars. Today's lesson is on transversals and parallel lines, as well as proving lines are parallel. The essential question is, how can congruency be determined for triangles, and if so, what properties about them can be concluded? And today's lesson is just one more step in answering that essential question. The specific lesson objective for today is that you will be able to identify angle pairs formed by a transversal intersecting two coplanar lines. Let's go ahead and get started. On the left-hand side, don't forget we have our questions margin. If you have any questions, write them there. Or if the notes answer any questions for you, you can write those questions there as well. And this lesson is very vocabulary rich, so please have a highlighter ready, and please take special care to commit some of these terms to memory, because they are terms that we will be talking about for the rest of the school year. Getting started. A transversal is a line that intersects two coplanar points at two different points. In the figure, line T, right here, is the transversal. And we know it's a transversal because it is intersecting this line right here, and it's intersecting this line right there. So it's a line that's intersecting two coplanar point lines at two different points. Okay? Corresponding angles lie on the same side of the transversal and on the same side of the intersected lines. And here's an example of corresponding angles. Corresponding angles would be maybe angle 4 and angle 8. Okay, they're on the same side of the transversal, they're below the transversal, and if you look, angle 4 is to the left of this line, and angle 8 is to the left of this line as well, so they're corresponding angles. Go ahead and see if you can find another set of corresponding angles. Okay. Angles 1 and angle 5 are corresponding, angles 2 and angle 6 are corresponding, and angles 3 and angle 7 are also corresponding. They're on the same side of the transversal, and they're in the same spot of the intersected lines as well. Okay. That's corresponding angles. Moving on. Same side interior angles lie on the same side of the transversal and between intersected lines. And that should make a lot of sense. Same side, lie on the same side. And some examples of same side interior angles would be angle 3 and angle 8. See if you can please identify the other pair of same side interior angles. Hopefully you noted that angle 2 and angle 5 are also same side interior angles. Go ahead and moving on. Alternate interior angles are non-adjacent angles that lie on opposite sides of the transversal between the intersected lines. So those are non-adjacent angles that lie on opposite sides of the transversal, be still between the intersected lines. And I just realized I forgot to highlight the word between up here. That was the missing word. So some examples of alternate interior angles would be angle 2 and angle 8. They lie on opposite sides of the transversal, so angle 2 is on top of the transversal, angle 8 is underneath the transversal. But it's still between the intersected lines. Go ahead and see if you can find the other pair of alternate interior angles. And hopefully you identified 5 and 3 as the other pair of alternate interior angles. Okay. One thing that I highly suggest is that you're writing these angle measurements down on your notes, so that way you can refer back to them. You also have examples down farther on your notes, but as I'm highlighting these, if you want to write these next to the examples, for example, we just talked about the alternate interior angles. If you wanted to write angle 3 and angle 5, I'm using my mouse on the smartboard today, so I'm a little bit slower at that, but obviously as I'm saying them and I'm highlighting them, hopefully you're highlighting them or writing them down, because you're doing it on one image. So it's your call, but I would definitely suggest writing these examples down as we are moving along. Okay, and we're going to keep on going. Our next type of angles are alternate exterior angles. And alternate exterior angles lie on opposite sides of the transversal, and they lie outside of the intersected lines. So think about the word interior means inside, and they were between the lines. Exterior means outside, and so they are indeed outside. And some examples of alternate, some examples of alternate exterior lines would be, alternate exterior angles would be 4 and 6. They're on opposite sides of the transversal. 6 is above, 4 is below, and they are both outside. So they're not inside the interior, they're outside. See if you can identify the other pair of alternate exterior angles. And hopefully you identified 1 and 7. Okay, they're opposite of each other and they're exterior. Okay, moving on. Parallel lines lie in the same plane and they never intersect. Now that's something you should be very, very, very comfortable with. They never intersect. They're never going to touch each other. That means that there's equal distance between them at all times. So if there's 5 meters in between them at this point, there's still 5 meters in between them at this point. So they never, never intersect. In this particular figure, line L is parallel to line M, and so we write it L parallel to M, and this is the symbol that means parallel. Okay? The arrows on the lines indicate that they are indeed parallel, so these arrows as well indicate that they are indeed parallel. When parallel lines are cut by a transversal, the angle pairs formed are either congruent or supplementary. So when a transversal cuts these parallel lines, these different angle pairs are either going to be equal to each other, which is what the word congruent means, or they're going to be supplementary. And what does the word supplementary mean again? So they're going to be congruent or they're going to be supplementary. And supplementary means they're going to add up to 180 degrees. And we talked about that last lesson. Okay? So looking at some of these different postulates. So we've talked about these different types of angles, and now we're going to actually work with postulates that relate to them. So the same side interior angles postulate says if two parallel lines are cut by a transversal, then the pairs of same side interior angles are supplementary. And again, what does the word supplementary means? It means that it adds up to 180 degrees. And here's an example of same side interior angles. So angle 3 and angle 5, they're same side interior angles. They're supplementary. These two angles will add up to 180 degrees. Okay? Again, look at the title of the postulate, same side interior. And if you think about it, use it logically, they're on the same side and they are interior. Moving on, the alternate interior angles theorem. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles have the same measure. That means that they are congruent to each other. So alternate interior, angles 4 and angles 5, they have the same measure. They are congruent. So angle 4 is 45 degrees. Angle 5 will also be 45 degrees. The corresponding angles theorem. If two parallel lines, line P and line Q, are cut by a transversal, T, then the pairs of corresponding angles also have the same measure. Those angles are also congruent to each other. And lastly, the alternate exterior angles theorem. If a parallel line is cut by a transversal, then the pairs of alternate interior angles have the same measure again. So again, those angles are congruent. So if 1 is 97 degrees, then 8 would also be 97 degrees. Okay? So these are, we just talked about one postulate and 3 theorems, but those theorems make a lot of sense based off of the name of them. Same side interior angles postulate, same side interior angles. Alternate interior angles theorem, alternate interior angles. Corresponding angles theorem, corresponding angles. Alternate exterior angles theorem, alternate exterior angles. Okay? So let's do some practice now. I want you to identify all pairs of corresponding angles. Go ahead, and I will identify one for you, and then you're going to identify the rest. Okay? So all pairs, I'm going to change this to a pen. Corresponding angles, I see that angle 1 and angle 5 are corresponding angles. So angle 1 and angle 5 are corresponding angles. Go ahead and pause this video and find the other 3 pairs of corresponding angles. Okay, hopefully you found that angle 4 and angle 8 are corresponding. Angle 2 and angle 6 are corresponding. And then angle 3 and angle 7 are corresponding. They're on the same side of the transversal and they're on the same side of the parallel lines. Okay? So those are all your pairs of corresponding angles. So now we're going to go into the alternate interior angles. And here we have exactly 2 pairs of alternate interior angles. And again, I will show you one of the pairs and you will find the other pair. So alternate means opposite of each other. Interior means inside. So angle 4 and angle 6. Angle 4 and angle 6. Go ahead and pause the video and find the other pair of alternate interior angles. Okay. Hopefully you found that angle 3 and angle 5 was the other pair. Angle 3 and angle 5. Together, that pair is the other pair of alternate interior angles. Moving on, let's find our alternate exterior angles. And again, here we have 2 pairs. Angle 1 and angle 7 is 1 pair of alternate exterior angles. So please go ahead and pause the video and find the other pair. The other pair of alternate exterior angles would be angle 2 and angle 8. They are alternate from each other, and they are the exterior angles. They are on the outside. Okay? And lastly, we're going to find our same side interior angles. And again, there are 2 pairs of same side interior angles here. 1 pair is angle 4 and angle 5. So angle 4 and angle 5. Go ahead and pause the video and see if you can find the second pair. And our other pair of our other pair of same side interior angles is angle 3 and angle 6. They are on the same side of this transversal. They're both on the right-hand side of the transversal, and they're in between the parallel lines, okay? I did not mean to write on that, sorry, my bad. They're in between the parallel lines. So angle 3 and angle 6 are same side interior angles. Now that we know this, we can use this information to find the values of missing pieces. So first of all, we want to find the value of x. And we know that this angle is 113 degrees. And for this angle, we have 3x minus 4. So what kind of angles are these? Think about that first. What kind of angles are they? We've learned 4 types. Are they alternate interior angles? Well, they're not on the inside, so they're not alternate interior. They're also not same side interior because they're not inside. So that leaves us with alternate exterior or corresponding. And by looking at them, I see that 113 is above the transversal and 3x minus 4 is below the transversal. So since they're on the opposite side, they are indeed alternate exterior angles. So because of that, if we look back at our information that we have from the beginning, it says that alternate exterior angles have the same measure. So I know that 3x minus 4 equals 113. So this angle, 3x minus 4, is equal to 113. So I need to get x by itself. I'm going to find the value of x, so I'm going to add 4 to both sides. And when I add 4 to both sides, on the left I have 3x left, and on the right I have 117. How do I get rid of x? Divide by 3, and x equals 39. Okay? Be careful to notice that x is not 39 degrees because I'm plugging x in for a value right here, and when I plug x in, it gives me a total value which I then apply the degree sign to, but x by itself is only 39 degrees. And how can I check this? Well, I could check it by plugging 39 in, multiplying it by 3, and subtracting 4, and I should get 117. Okay? So you have to know what types of angles these are to solve this. If you did not know they were alternate exterior, then you may not realize they are congruent to each other. But I promise you, when I'm giving you problems like this to solve, I will always give you enough information to solve them. Example number 3. we're going to find the measure of angle WUV. We're going to explain how we found it using postulates, theorems, and or algebraic reasoning. So what they're trying to get us to find is the measure of WUV. And so we already know it's 22x plus 25. So that I know, but I don't know what x stands for, so I don't know the total value. But I know it's 22x plus 25. So I have this angle, and the only other measurement I have is let me actually write it. The only other measurement I have is angle SRP. SRP. So I have two angles here. Now, angle WUV and angle SRP, I know they're not interior angles because they're not on the inside. These would be the interior angles right here. So they're not interior angles. So they're not same side interior angles. They're also not alternate interior angles. That either leaves corresponding or it leaves alternate exterior. Now, if we look back at our previous example, these were alternate exterior angles. One was on the top of the transversal and one was below the transversal. Our new example, they're both below the transversal, okay? But they're also not corresponding angles either, because this one, WUV, is to the right of the transverse. I'm sorry, it's to the right of the parallel line, but PRS is to the left of the parallel line. So they're not corresponding either, so I have to figure something else out. However, what I do know is that WUV is corresponding to this angle right here. It's in the same position as this angle. They're both below the transversal and they're both to the right of the parallel lines. So the corresponding angles would be the same. That being said, this particular angle is what with this angle? What do we know about this angle right here? This angle, sorry, and this angle together. What do we know about them together? Well, they are a linear pair because it's a line that was cut. I can't say it was cut in half. I can't even say it was bisected, but it was intersected, I should say, by a transversal. So the two angles formed make a linear pair. So I know the angle WUV is 22x plus 25, and I know it's congruent to this angle right here because they're corresponding angles. And I know this angle, WUV's corresponding angle, plus 9x are a linear pair, or they're supplementary. So what does that mean, supplementary? It means that it adds up to 180. So 22x plus 25 plus 9x has to equal 180 degrees. And I'm going to walk you through that one more time. Let me erase what I have on the board. Okay? So I know that our angle in question, which I'm going to notate right here, is corresponding to this angle. I don't even have a measurement for that angle, but I know it's corresponding to this angle. But I know that that angle and this angle right here are supplementary, or a linear pair, because it's a line intersected by another line. So the angles formed are a linear pair. Linear pair are supplementary, they add up to 180. So I know that I have 9x, and then this angle is equal to 22x plus 25 because it is congruent to that angle. So I have 31x plus 25 equals 180. To get the x by itself, I will subtract 25 from both sides. So I have 31x equals 155. And dividing by 31 to get x by itself. And again, I told you guys I was using my mouse tonight, not the smartboard, so I apologize. It's a little shakier. X equals 51. Now, I'm sorry, x is not equal to 51, my bad. X equals 5. Getting ahead of myself. X equals 5. 155 divided by 31 is 5. Now, what you have to be careful about is the problem does not ask you to find what x equals. It asks you to find the measure of WUV. So now I know that x equals 5. I can plug that in for the x and solve. So go ahead and plug that in and solve for x, and then see if you got the right answer. Okay. And if you plug it in and solve, 22 times 5 is 110, plus 25 is 135. So the measure of angle WV is 135. Okay? I know this seemed a little tricky, but once you know the angles and what they're called, you're able to easily switch them in and out and solve. So I was able to find this using corresponding angles, finding what angle is corresponding to WV, and then knowing that two angles were supplementary and were a linear pair. Then I solved for x and substituted x in and found my measure of WUV. Okay, we are almost done. Moving on to a little bit more vocabulary. If two lines, these are all converses, and you'll need to write this in. A converse is a statement that switches the hypothesis and the conclusion of a conditional statement. So originally we were talking about corresponding angles, and we said that if two lines are cut by a transversal, then the pairs of corresponding angles have the same measure. So now we're doing the opposite. We're saying if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. Before we were saying if the lines are parallel, then the angles are congruent. But now we're saying if the angles are congruent, then the lines are parallel. So converse means opposite. So now we're taking the information we have and flipping it around so that way the information can prove something else. Alternate interior angles converse. If two lines are cut by a transversal so that the alternate interior angles are congruent, then again, the lines are parallel. The alternate exterior angles converse says, if two lines are cut by a transversal so that the alternate exterior angles are congruent, then the lines are parallel. And again, notice these converses make a lot of sense to what they're called. The corresponding angles talks about corresponding angles. Alternate interior angles converse talks about alternate interior angles, and so on. Same set interior angles converse. If two lines are cut by a transversal, so the consecutive interior angles are supplementary, then the lines are parallel. Okay? And moving right along. So we are going to find the value of x that makes M parallel to N. So what kind of angles are these? Well, in order for M and N to be parallel, that means that these two angles, which are corresponding angles, have to be congruent. So, I apologize, I have the highlighter on still. So 71 has to equal 2x plus 3. Okay? In order for these two lines to be parallel, these two angles have to be corresponding, which means they have to be congruent to each other. So we're finding the value of x that makes this true. We subtract 3 from both sides. On the left, I have 68. On the right, I have 2x. Divided by 2 to get x by itself. And x equals 34. So if x is 34, then these angles, this angle and this angle, are both 71 degrees, and therefore that means that since the corresponding angles are congruent, the lines are parallel. We're proving the converse. Last, we have our summary. Go ahead and take a few minutes and write what we learned. As I told you in the beginning, this was a very vocabulary-rich lesson, and they are theorems and postulates we're going to be referring back to all year long. But they are very logical. We actually really covered 8 for postulates and theorems, and then they're converses, but they're very logical. If the title says alternate interior angles, the content is dealing with alternate interior angles, but you must use your logic in order to figure that out. Okay? Thank you guys so much. Please take a minute and write a summary. I'll see you next class.